everyone. Thanks for the intro. And thanks to the Tech Academy for setting this up. I initially had a conversation not too long ago with Eric, and we really resonated on the uh, deeper, deeper values of
Hey, Mohammed. Yeah, just go ahead and unmute your mic.
Oh, how long
There
was
we
I
go.
on mute? Was I on mute on
Uh,
the entire time?
just a few seconds. It wasn't bad.
Okay.
Continue.
So, yeah, I touched base with Eric. I'm here now, and one of the main things I want to do in this talk is talk about the talent market. So at one point, I was looking for a job as a data scientist. I was a bit lost. Then I ended up working as a data scientist, and now I run a performance-based AI lab, uh, aka a data science company. So in the past couple of years, I got to see this talent market from various perspectives, from a person looking for a job. So in terms of talent, I got to see it in terms of hiring myself, from the talent seekers, and also talking to fellow founders that are hiring. So I think there's quite a bit of insights that I can give just from my own experience. So I'll ramble and provide quite a bit of context in terms of what my story is. And then towards the end, it'll be uh, providing this sort of algorithm of how I would go about it if I were to do it again, or how I would explain my story uh, in regards to breaking into a career or switching a career, which I'm sure uh, is relevant to a lot of you here. So as mentioned, I am the co-founder and CEO of Trilemma Capital. We are a performance-based AI lab. We offer expertise as a service, but I think it is interesting to talk about how I got here. So Trilemma has been going on since May, but prior to May, what made me and my co-founder put everything else aside to do this full time? Now, prior to Trilemma, I was working as a blockchain data scientist, blockchain researcher at a digital asset company based in Vancouver. I was the 40th hire, and then by the time I left, they had over 100 employees. So the company had a lot of success, and they grew really well. Uh, my job there was to basically work with on-chain data. So this is data from, let's say, Bitcoin, from Ethereum, and to deploy various models, various machine learning models for institutional clients. And at the same time, this is where I was working alongside my current co-founder, Matt Fulton, and we were leading the R&D team. And simultaneously for Matt, actually, he was working on his PhD. He was doing brain tumor forecasting in a bioinformatics program. Now, my background, where I actually met Matt at the University of British Columbia, I was doing math and economics, and I wanted to be a quant, uh, basically really into financial options and the mathematics behind them, the stochastic differential equations, all that nerdy stuff. And Matt was busy with all the clinical side of things, and then deploying his deep learning models for understanding brain tumor forecasting. But naturally, we're having these conversations every day, and we're friends, so we're having casual conversations outside of work, and we our brains intersected on using those models that Matt is using to forecast brain tumors, and applying them to Bitcoin ETF options trading. So it mixes in our expertise in generating value from on-chain data. It mixes Matt's expertise in developing these and training these deep learning models for understanding brain tumors, and my passion for options and all the stuff that I was looking into. So this is about Q4 of last year. Now, our idea turns into a strategy. a trading strategy. And that's really when it all started. The opportunity cost of us staying at whatever we were up to, which was Aquanow, and for Matt, Aquanow and his PhD, became extremely high. And in April, we left everything aside. I left Aquanow, Matt left Aquanow, and that's the digital asset company that I was mentioning. And Matt also left his PhD. In fact, in doing so, he also turned down over 300,000 USD of scholarships and awards. So that's to somehow quantify this opportunity cost that we were working with. And we started Trilemma Capital. That's where the capital and the name comes from. It's very hedge fundy. So we as till now, we've been deploying the strategy and it's been doing really well for us. But we've also abstracted and generalized those models to work on various projects and to work with various people. So one example of that is that currently Matt is working with New York Medical College and Westchester Hospital to provide clinical data science for stroke detection, being able to improve stroke patient outcomes, and using various models to work on things like being able to detect if a person's face is droopy. Earlier in July, I came from the Earthquake Engineering World Conference in Milan, and those same models that are relevant for brain tumor forecasting. For instance, if you put an EEG cap on someone's head and they pick up signals from various locations of your brain over time, uh, I was applying that to the seismic world, where they have a structure and they place these instruments across the structure in various parts of the structure that pick up vibrations over time. And now you could do things like predict an earthquake 10 seconds prior to it happening. So that's where the AI lab comes in. We're basically going from door to door, talking to really interesting people and seeing where we could utilize our expertise. Now, simultaneously, the part that is really relevant to this discussion and everyone here is the data science tournament that we're running. So in July, we ran the beta tournament. It's actually about to wrap up, a month long, and it's a free data science tournament where you predict Bitcoin's returns for the next week for 4 weeks in a row. And there's no data sets. You enter the tournament. Bitcoin is public. It's anyone can go on chain and get whatever data they want. So you try to extract whatever sort of signal that you find interesting. Maybe it's on-chain data, maybe it's off-chain data, and you build these models to be able to provide the best time series forecast. And currently they're competing. That tournament is about to be wrapped up. We had 214 teams, or we currently have 214 teams participating, which was a really nice showing for a tournament that we just started, beta tournament. And you can tell that it's a beta tournament because it has no platform. It's just you sign up through Google Form and you submit your forecast through a Google Form, so very primitive. But we're very optimistic about the value that this tournament can provide. In fact, we're expecting 3,000 participants by the end of 2024. Now, there's 15 people here. The point of me mentioning the tournament is not to get an additional 15 participants to enter for the next tournament starting in September. There's a deeper reason behind the tournament, and that is the relevant part for this discussion. The deeper reason is that the tournament is solving the problem of an inefficient talent market. And I say that the talent market is inefficient because oftentimes talent seekers filter this large pool of talent by only considering candidates that have certain social proxies or certain social signals. For instance, they might only hire MIT grads. They might only hire you if you have some FANG company on your resume. And I'm not gonna say that if you only hire math PhDs from MIT, you're not gonna get performance. You're not gonna get a really smart individual working at your company. But what I am gonna say is that if you're only conditioning on finding talent, and you're looking at this objective, this never implies just a math PhD from MIT. So you're creating a lot of false negatives. And when you create a lot of false negatives and you leave out a large amount of people in this talent pool, which a lot of you are in, you lose a lot of value. So that's exactly what the tournament is doing. It's picking up on that value in this inefficient talent market, because it's free to enter and anyone can enter. We don't interview you to say, hey, you can be invited to this hackathon, to this tournament, which, by the way, is something that happens. For instance, various hedge funds often hire through these sort of tournaments, but you have to get invited, and you probably only get invited if, let's say, you're from a top school, or you have some experience on your resume that fulfills their criteria for, social signals. And to clarify for the tournament, the only real condition is that you have a verified LinkedIn and you have a verified Google account, that you're a real person. So you could be a PhD with immense experience in time series forecasting. You could be a high schooler that doesn't even know what time series forecasting means. But at the end of the tournament, when we rank them based on how well the forecasts are, which is very objective, it's literally just a distance between the actual value and the forecasted value. That is a true ranking of the talent pool. So we might get a story like a high school dropout wins the tournament and the PhD places in 10th place. There's a lot of value in that, and there's a lot of value of having access to such a large talent pool. But the main reason that I'm bringing it up is to allow everyone to realize the sort of environment that they're in, specifically the sort of environment that is heavily in favor of the talent seekers as opposed to the talent, where they can play this game and just do this sort of filtering. And then use that and use, I would say, I don't want to make any absolute statements and say, you should do this, you should follow this recipe. I'm just going to say a recipe that worked for me in terms of ending up with a career that makes you happy, ending up with a job that you love. Maybe subconsciously you thought that you wanted to get into engineering because you saw a post somewhere out there that an OpenAI average salary engineer is 750K USD a year. But believe me, there's no value in making $1 million a year when you're not happy. And really, I think the biggest question for everyone here to answer is, have you fallen in love yet? Have you discovered the topic, the field that genuinely piques your interest? It can still be a love-hate relationship. For me, I love math, but I definitely didn't love math when I had a final exam the next day, or when I was struggling with assignments and the deadline was tomorrow. It could be a love-hate relationship, but at the end of the day, is that something that you wouldn't rather replace with anything else? And if you've already answered that question and you're set on engineering, you're set that you want to be a back-end engineer because you love building things, and ever since you were little, it amazed you to be able to point at the things that you've built and really admire that. Or you want to be a front end because you love designing, you want to be a data scientist because of whatever reason, then I think you're if it was a loading bar, It's not like you're 10% of the way. In my eyes, you're 90% of the way. The remaining 10% is taking the shortest path to doing what you love. But prior to touching on that and talking about the shortest path, I think it's almost cliche for me to come in here and say, hey, find what you love and you've done most of the work. That's much easier said than done. So I can explain for me why I'm so happy doing what I'm doing, running this company, and why I wouldn't want to be doing anything else. And maybe my story or the little things that inspired me and helped me fall in love uh, can help some of you uh, create a similar story for yourselves. So for me, really, data science is a beautiful uh, topic because of its generalizability. And I think one of the first times that I was really amazed by how generalizability can be valuable was in the office hours of my partial differential equations professor in my undergrad. And in his office hour, students would come up, have various questions about whatever they have questions about, their homework or midterms, and he would somehow break the ice by asking them what their major was. And that class was very diverse. So there would be some chemistry majors, there'd be some physics majors, engineering majors. Uh, for me, for instance, I was interested in financial engineering. Uh, when I was mentioning that I wanted to be a quant, that is the sort of field that you'd study if you wanted to be a quant. And then he would take that and he would give you an equation, regardless of what you said your background was, and he would talk to you about it. And he would really get you interested in that specific equation that's relevant to your domain. So for me, he talked to me about Black-Scholes, which is an equation for pricing options. And he mentioned how it's derived from the heat equation that we're currently studying. But he was able to do this with every student. And that sort of generalizability really fascinated me. And perhaps that's why I'm here today with this AI lab. It's amazing that I can have a conversation with neurosurgeons in regards to brain tumor forecasting and stroke detection and Alzheimer's detection, all those sort of things that they might be interested in doing. I can have a conversation with seismic engineers in terms of health monitoring and early warning and all those sort of things. And I could talk to people in finance. I could talk to almost anyone, given that the intersection is this data-driven topic of how you can provide value from generating value from data. That's one of the things that I genuinely really like. Also, the fact of being a reductionist, being able to simplify things down to their axiom. Uh, Maybe I like math because I'm a reductionist, or I'm a reductionist because I like math. But that's the sort of thing that, for me, I don't have any more exams. I don't have any more studying to do. But sometimes when I eat my lunch, I put my phone in front of me and I watch lectures. I watch math lectures. I watch. So that's a sign that you're doing something that you like. There isn't really a work-life split. You know, my leisure is my work. My work is my leisure. So that's really the first step. And it's also very valuable to be able to falsify what you don't like. So for instance, let's say you take a software engineering course and you're working in Java and you're going through all these design templates and all whatever software engineers do, and you hate it. I think that's also very valuable. Um, you're getting more context. It's a very Bayesian approach. You had some prior. You believe that you might have enjoyed software engineering. A lot of your friends are software engineers, and they're having fun in their FANG offices playing ping pong. So you take this course, you maybe do this boot camp or however way you get exposed to it, and then you find out that you hate it. I think that's also valuable. Now you're one step closer to finding what you love. But now the key part is, let's say someone in this Zoom meeting is set on data science. Now you want to take the shortest path to doing what you love because there's a opportunity cost of not doing what you love. It's very expensive if you found out that your passion is data science to do anything other than data science. So really, you have to think twice about anything that isn't a shortest path. For instance, you know, I think the first person that I have to criticize is myself. I enjoy these quantitative topics, mixing math, data science, all these things. But this was my mindset when I was in my undergrad. I'm gonna break into my career. I'm gonna get a data science job. I'm going to work a bit in industry, and then I'm going to come back and do a master's because my mathematical maturity is not high enough. Sure, I did real analysis, I did stochastic processes, but I should take measure theory, and then after measure theory, I should take functional analysis, and then I really enjoy PDEs, so I should take a PDE course that has a prerequisite of functional analysis, and then I should take a stochastic calculus, and it's endless. There's always things to learn. There's always something to do that's not just the work. So then soon I realized, and a lot of my realization actually came from talking to Matt, my co-founder, is that why do you need to do a math master's to to learn, let's say, measure theoretic probability or a functional distribution based partial differential equations course? Work as a data scientist, work on projects that force you to learn those topics, to learn those things. So really, all you really need is some basic enough information to be able to confidently say that you love what you're doing. You can't say you love what you're doing when you have no idea what it is. So then you kind of have to go back to that first step. Do I genuinely love it? But once you have that, then I think it's a form of procrastination to always want to have some additional step prior to, hey, before I actually work as a data scientist, let me do this, let me do that. No, you can work as a data scientist immediately. That's the beauty of tech, is that you're eligible to take the shortest path. I can't give this advice to a lawyer. I can't say, hey, you're currently a law student. Why are you waiting to pass your bar? Just go out and give legal advice to other firms. No, they'll go to jail. I can't say that to a doctor. Hey, you really love neurosurgery. Just practice on your friends. But luckily, there's no such thing for software engineering or data science. You can just do it on your own laptop. You can work on a project. You can get an internship. And you don't have to worry that you're not ready. Like for me, why am I worrying that I don't have a PhD level understanding of math? I mean, there's always more to learn. And the one thing that can help comfort me in a way is that I'm not going to be hired as the lead researcher at Google's DeepMind. I'm probably going to get an internship that's fitting to my skill set, and I'm going to learn from there. I'm going to grow. So really, it's just those two main things: finding what you love. Once you found out what you love, you're, in my eyes, 90% of the way there. Try to take the shortest path. Try to take accountability and do something as soon as possible about that, whether it's a passion project, whether it's reaching out to various startups and asking them what sort of projects they're working on. But you have that privilege of doing that because you guys are in tech. And really, I think that's all I have to say for the monologue. And I'd love to answer any sort of questions that I didn't go over throughout my discussion.
All right. No, that's really good, Mohammed, and really good insight into looking for your career in technology. And I like the way you really made it really kind of let everyone know to find something they love.
Yeah.
And that is kind of a key. And a great thing about technology is it gives you a lot of avenues. So if you're into data science, you can definitely, and you're into mathematics and numbers, you can go that route. Or if you like software, if you like web design, and UI, you can go into building websites. A lot of different avenues you can take. And Mohammed found what he really loved. He's a numbers guy. And yeah, so that's really good stuff. We will open it up to questions. You can definitely ask any questions in the chat, and I will open up the microphones as well. So if you want to ask a question verbally, go ahead and open up your microphone, and we can ask Mohammed. It's really insightful, and there's a lot of good questions that can be asked. So I'll ask this, Mohammed. What do you see the future in data science with technology moving so quickly and um, exponentially progressing? How do you see data science going in the next 10 years?
Yeah, I think data is an opportunity cost as well. So it doesn't matter what industry you're in. If you're sitting on data, it's a it's a lost value if you're not doing anything interesting with it. There's a lot of interesting insights to derive from that data, whether it's clinical, whether it's, let's say, seismic. Um, so they're going to start realizing and quantifying that opportunity cost of how expensive it is to not do any sort of data science work in that domain, because currently a lot of domains aren't uh, very ML heavy, very data driven. They've been successful without being very data driven. For instance, when I go to a hospital, the first thing that happens is triage. Basically, a nurse checks my vitals, asks me questions, and tries to assess my risk. The same sort of triage that happens to me if I were to go to a hospital today probably took place for my grandparents. But between today and, let's say, a couple decades ago, a lot has changed. A lot of new models, a lot of new methodologies, and in fact, there's much more effective ways of doing that triage. Let's say through using a data-driven approach and doing some sort of risk stratification. Let's say you go in with an Apple Watch, they can tap into not only your current vitals, but your historical vitals, and look into your heart rate, look into all these sort of things, and then provide a much more accurate risk score for, hey, should you be rushed in immediately, or are you good to wait for another, let's say, 3 hours? Um, Long story short, it's going to be much more prevalent in places where it wasn't prevalent before.
Yeah, and implementing artificial intelligence with data science. I think it's pretty amazing to think where it could be, going into the future, the next 5 years, next 10 years, just because of that exponential progression.
Mm-hmm.
So um, now with the forecasting, so Trilemma, so you're into forecasting cryptocurrency. That's kind of the main business idea.
That's how we started. We were providing these probabilistic forecasts of the Bitcoin ETF options, which basically means Bitcoin on regulated exchanges, and options are just a way to place a financial bet. Is it over or under a certain price by a certain point? So you can almost think of it as like a binary classification problem. And yeah, that's how everything started, and we left everything aside to work on Trilemma.
Very nice, very nice. And can your company start doing some lottery forecasting?
Lottery forecasting. Well, some things are random, and by definition, it's unforecastable. So if I create some random noise, by definition, you can't forecast that.
There you
Or
go.
forecasting. That's a good question. Sometimes it sounds very magical. Sounds like I'm some sort of oracle or wizard when I say that I can Do I have an edge in some forecasting? I can help, let's say, forecast an earthquake 10 seconds prior to it happening, or whatever the application might be. But really, all of us forecast all the time. I mean, the whole cliche thing of never judge a book by its cover. In a way, that's forecasting. You're using a person's appearance, you're using a person's reputation, which is past and present data, to pull that into the future and extrapolate what that person might be like and what your relationship might be like with that person. Really, it's the same exact thing. Don't get lost in the mumbo jumbo of, oh, this is a deep learning model, this is a transformer. Really, all you're trying to do is just pick up patterns and trends and cycles and data and basically copy paste that into the future. Some forecasts are more accurate than others, but at the end of the day, all models are wrong. It's just some are useful.
All right. And does anyone else? Well, looks like we have a question from Dan Bryan. And he asks, how do you view AI's role in tech in the future, and how does that role impact people's role in tech?
Um, there's a company named Fast AI, and their slogan is, I think, AI or neural networks. Their slogan is, let's make neural networks uncool. And the point of that is no one really talks about statistics as this buzzword, but AI is a buzzword, and everyone likes to talk about it, be included in it. But eventually, it's going to be a part of everything, and uh, perhaps that sort of buzzword of, whoa, this is statistical modeling. It will start to die down because of its prevalence. That's my one take, is that perhaps maybe I'm also trying to help work on that agenda of making it uncool by just making it relevant in all areas, in most areas. But the other part of the question impacts people's role in tech. Uh, I think as a software engineer, specifically, I'll say my experience as a data scientist, before and after ChatGPT, uh, it looked very different. So don't get me wrong, before ChatGPT, I was never like in the movies where you see a montage of someone, or the funny part is you watch some YouTube tutorials on people working on projects. I've done this before in my undergrad, and it's kind of crazy how they just type out the entire project in one go in 30 minutes, and they just typed out, let's say, 1,000 lines of code. That was never me. I think most people never work like that. Before ChatGPT, I was going back to my previous work, copy pasting this code block. I was going on, let's say, Stack Overflow. Oh, this is how you work on this solution. Copy paste that. It was very modular. I'm just cutting, pasting everything, tweaking, let's say, little syntax, and then eventually I get something that works. Now my IDE is ChatGPT. I'm like, hey, write code that reads this data frame, parse the index as a date time, blah, 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 da, 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 types out my code, copy paste. Okay, works good. Next one, copy paste, works good. So as a software engineer, it's gonna help you a lot in not having to worry about being that YouTuber that provides the project and types out 1,000 lines of code and looks like a wizard. You can really utilize these LLMs and tools like Copilot to make your life a lot easier. So it's almost as if you have a secretary. It's almost as if productivity is going to go up. If the pessimistic way to look at it is, oh, well, now we need less software engineers. The optimistic way to look at it is, well, we can now, rather than, let's say, producing 1 million lines of code, we can now produce 10 million lines of code. So let's keep the same amount of software engineers. Let's just be more productive as a company.
Yeah, I think that's a really good point. It's currently in the state it's in, it is a great assistant, and
Hmm.
it can, produce the code you need quickly, but you're still going to have to modify it. So you're still going to have to,
Yeah.
tweak it the way you want it. Whatever company you're working for, they're going to need different variables and that kind of thing. So you will need to do that. But what it's going to do is just make everyone that much more efficient,
Hmm.
and you can get a lot more work done in a short amount of time.
Yeah, exactly. I mean, you have to still realize that LLMs hallucinate, and if you don't know any basics, you're not going to be able to just trust thousand line of codes that ChatGPT just provides you. Sometimes there's been times where I get into this uh, loop of, hey, this is wrong, this is the error, try again, try something else, another error, try something else, another error, and then I have to jump in and say, okay, now I actually have to unfortunately roll up my sleeves and write some code for once. But I think as context length uh, increases, and there's some interesting papers on infinite context length, it's going to be much more relevant beyond data scientists. So data scientists, I mean, we don't really write a lot of code. We usually just work with notebooks, and or maybe I'm deploying a Lambda on AWS. So maybe you're looking at, let's say, like 300 lines of code, 500 lines of code per Lambda. Software engineers, you could be working on really large projects, and that's where um, I think currently, at least that's my experience. When I was working at my previous company and I was talking to other software engineers, they weren't utilizing ChatGPT for coding as much as I was. I mean, I was purely like, if ChatGPT went down for the day, so did I. I wouldn't I wouldn't be productive. But the software engineers were not really that bullish on it, other than using Copilot for like autofilling the line that they're currently using. And it makes sense given that the way that they code is very different than the way that I code.
Yeah, and I think it's interesting that Microsoft bought majority share in OpenAI, and now they use all of ChatGPT or OpenAI's technology for their Copilot.
Yeah,
So
I think I'm I was jealous of I'm still jealous of students going through their undergrad and their studies now that they have access to ChatGPT, because unfortunately when I was doing my undergrad, we had to use something named Chegg, not very efficient. You take a picture and then some person answers it and then takes a picture and then say, oh, okay, so that's how you do the proof. Or you would check, of course, you can check a textbook, or you can check Stack Exchange. Now, I mean, it's just going to be monotonically increasing in the near future in terms of newer versions of these LLMs are just going to become more and more powerful and provide more and more value. And yeah, I think people in the past that didn't have this tool would be very jealous of everyone now.
yeah, and there was a time also where people didn't have Google search.
Yeah.
Back in a time when they had to go to the library.
Yeah, what's that? Yeah. I mean, yeah, it's a transformation. It's a digital transformation. Um, it's amazing to be a part of it, and I think regardless of your niche, your expertise, so you don't suddenly have to go and read publications on the most cutting edge work in neural networks, if let's say you're a front end, but you should be aware of the tools and the resources, just so you don't fall behind.
Yeah, no, it's a good point. And OpenAI is coming out with a new search engine. You've probably heard of it. It's Search GPT.
Hmm. Yeah, that I mean, I'm looking forward to all these new things. I personally only use ChatGPT. That's the only subscription I have. I don't think you need to, uh, rack up hundreds of dollars of monthly subscriptions. For me, ChatGPT does, uh, or just my ChatGPT subscription is more than enough for the work that I do.
Yeah. Yeah, and it's basically the same price as Netflix. So
Yeah,
it's not much.
yeah, exactly,
But yeah, no,
exactly.
I've got I subscribe to it as well.
Hmm.
Um, Now, where do you see the future of cryptocurrency and blockchain?
All right, that's a tough question. To make it clear in terms of my background, uh, I'm not a very Web3 person to be deploying smart contracts and, being deep into the space and telling you the latest, Ethereum improvement proposals. I know people in my network that are much more uh, are much better suited to answer that question. But I think it's one of those technologies for me, that isn't going away, regardless of all the noise that might be there. Uh, a couple years ago, Web3 and crypto was a buzzword as well. Now it's kind of dying down again. It makes sense given the markets, but maybe there's some sort of irrationality, and you don't really hear about it a lot. But during this time, that's when most things get built. A lot of the interesting innovations get built in the choppy and bearish markets, and then suddenly, in let's say December, you might wake up and Bitcoin hits, let's say, 100K USD, and now suddenly, oh, it's a buzzword again, and there's a lot of advancements. There's a lot of interesting things going on. So I think the advancements and the technology itself is not going anywhere. Uh, as with anything that has been or is a buzzword, there's a lot of noise. I mean, as of now, there's a lot of AI companies that have no business being AI companies, and maybe that's because of the incentives set by VCs. So VCs love throwing millions of dollars at AI companies. Their agenda is, hey, let's see which company is using generative AI. And let's say you're a real estate company, no one's really interested, but now you're a AI real estate company, and now you're swimming in money. So a lot of that noise, I think, will dissipate, but the genuine innovations are not going anywhere.
So you haven't thought about changing the name to Trilemma AI?
Yeah, I mean, to be fair, I sometimes cringe when I have to say that, hey, I have background working with on-chain data, and we do we're an AI lab. It makes me feel like I'm partaking in the buzzwords. Uh, but yeah, I think it's very obvious when you talk to people whether they're genuinely in this space, or if they're just trying to hop on the hype, and it's more of a FOMO thing.
Yeah, and like you said, it's the current buzzword and the current thing that attracts venture capital and that kind of thing. So
Yeah,
do you hope the venture capital is coming towards data science companies also?
yeah. Data science is this is something that I've heard from someone actually, is that data science is not a sexy word like AI. So uh, really, for me, really, there's no difference. I mean, data science, stats, machine learning, deep learn, it's when we work on time series forecasting, we might run we might have an ensemble of various models. Some of those models might be statistical, models that have existed for, let's say, 50 years. Let's say some Holt-Winters exponential smoothing or whatever it might be. Some of those models might be machine learning, some, like profit or tree-based model. And some of those models might be deep learning, where, there are some sort of, let's say, transformer or some sort of vision model. But it's like I can't really make a distinction to say that, hey, my work is deep learning, my work is machine learning. I mean, it's very hard to even make a distinction between machine learning and statistical models. Oftentimes it's like it's the same thing, you know. So yeah, data science, AI, ML, really, it's, if you're interested in one, you're probably interested in all.
Yeah, makes sense.
Yeah.
And what what do you well, actually, what I wanted to ask, does anybody else have any questions? I don't want to hog up all the talk here. Gab, do you have any questions?
Yeah, I do have a question. So, when I was listening to Mohammed talk earlier, I could actually relate to a lot of stuff. So, before I went to tech, I was in the medical field. I was studying my pre-med, and hopefully, uh, my
Mhm.
parents were, of course, wishing that I go to med school in the future. But I was like, no, I'm not really into the medical field. What I really love was logic, and so I left the medical field, and I didn't really know what I wanted. All I know was that I love logic and numbers too. So that, hey, maybe computer engineering is the way to go for me. So I did that. And when I was doing my thesis, I tried to combine the things that I love. And these are logic and programming, and also agriculture. So I thought, that, hey, maybe I'll do my thesis in sustainable urban farming, and I did that exactly. But when I was doing that, I was forced to do the things that you mentioned earlier. When you were doing a project, you will be forced to learn a lot of the things that are needed to accomplish your project. And so there was, I also incorporate IoT in that thing because I want my studies to be relevant in like 10 years time, 5 years time, 10 years time. And IoT seems to be like the trend in some areas. It's like it's a future proof at this point. So my question will be, what skills would you suggest that these people or everyone learn, as the foundation if they want to maybe dive into the world of AI, machine learning, and data analytics?
Mhm. Um, I think quantitative tools are very important. Being able to, let's say, have the basics of math and probability are important, but it's tough because at the same time, saying that kind of creates this tunnel, and you just go down it, and you go deeper and deeper and deeper. Really, I think almost work backwards and find something interesting that is that catches your attention. Let's say time series forecasting. Oh, it's cool how you can predict future values from past and present, and just use that thing that interested you to, let's say, work on a personal project for your portfolio. And then you will naturally get to the math, the probability, the modeling. So don't start with the prerequisite and then work towards the project. Just be interested in a project. For instance, building some Sudoku solver. Oh, that sounds interesting. Okay, now you can, get an IDE, work on Java, or work on whatever language you're interested in, or work in Python. Um, so take a backwards approach. I think that would be the best way to just take the shortest path.
I mean, if I'm going to start a project, let's say tomorrow, because I want to get into this world of data analytics and machine learning, I
Mhm.
would personally would like to work on the most popular technologies in that industry. So what are those like popular technologies nowadays that are very in demand?
Well, time series forecasting is one of them for sure. Anytime you have temporal data, so data that's indexed by time, one of the immediate interesting things to work on is forecasting that data. And really, we live in a world with a temporal dimension. Everything happens with respect to time. So regardless of whether you consider it to be a time series or not, it inherently is a time series. You know, uh, and time series has a uh, it's a very broad it's a very sort of broad area. It's not just a univariate time series where real numbers are changing over time. You can have images changing over time, graphs changing over time, tensors changing over time. So I'm biased. I'm going to say time series is one of those areas. If you're interested in that, see how maybe you can work on something to do with marine biology. Let's see how you can work on maybe something related to finance, something related to whatever field that's interesting to you. Maybe explore. I mean, time series forecasting is also very lucrative. So if you happen to have good models that you can trade on, hedge funds are willing to pay you very high salaries and keep those models proprietary. So that's another part of it. And maybe that's why time series forecasting tends to be less public than, let's say, a vision model or something like that.
Any like programming language or framework specifically that are popular nowadays with companies?
Well, I'm just going to answer for data science. I've always used Python. In school, in academia, there tends to be some tendency towards R, specifically for statistical analyses. I'm not a fan of R. I just stick to Python. You could do a lot in Python. But
What are the
that's,
frameworks they use?
you mean libraries or?
Yeah, libraries too.
Well, you have to know pandas, NumPy, just the basics like matplotlib. Once you have those three, you could really work on most projects, and then additional libraries, like scikit-learn, and those are like you're now comfortable with working with data and working with exploration and visualizations. Now you can start maybe rolling up your sleeves and getting your hands dirty a bit and maybe working on some modeling. But the perfect answer to that would be you gotta work with the basics and then use ChatGPT to explore the in-depth models that I don't even know about. There's always some library out there that you will never be aware about because there's so many of them.
Good stuff, Mohammed. Great talk, real deep dive into data science and data analytics. We appreciate that. And I always kind of do wonder, some of the great scientists and mathematicians, what they would do if they had ChatGPT back in the day. So if you had Ramanujan or Einstein, what would have happened with ChatGPT if they had that? Just a thought.
Uh,
Just a thought.
well, I mean, you don't. Let's reframe that question and think about the current geniuses, like let's say Terence Tao. I think there was a post on LinkedIn or Twitter that he made. He was impressed and I think surprised by how one of those models was able to solve a lot of Olympiad questions. So I think they'd be impressed, given that Terence Tao is impressed and he's a modern day math genius. But how they actually use it, I couldn't tell you. All I know is that grandmasters use chess engines all the time, and it's changed the way that they study chess. Um, I'm not fit enough to answer how a math genius would use ChatGPT.
Yeah, just a thought. That's all.
Yeah, like if you were working on Colette's conjecture and it's an unsolved problem, maybe Terence Tao is talking to ChatGPT as we speak to, help solve that Millennium Prize problem. But those are conversations that I have no competency explaining or predicting.
Well, it's the kind of conversation you have at a happy hour on a Friday.
Maybe equivalent. Yeah.
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 All right, good stuff, Mohammed. Well, we appreciate your time and thank you for coming out and doing the talk for us. And just to let you know, both my cousins graduated UBC also, so
Nice.
that's a
Yeah.
good alma mater there.
Yeah. Love that.
Yeah, and if you're willing to, we'd love to have you in the future. And yeah, thanks for coming out and have a great weekend.
Thank you so much. Yeah, thanks to Tech Academy and everyone here for listening. I hope I was helpful in providing some sort of context to your futures.
No, it was really good and really 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 detailed, and it will help our graduates for sure.
I appreciate it. Thank you, everyone.
Okay.